The next lesson, recording, modelling with sine and cosine functions. I don't know if you'll need the calculator so much for this one, but just feel free to have it out if you want. So I'll rip through stuff. So we know the general form of sine and cosine functions are something A, B, C, D, with some sine stuff in it. Okay, good, it's kind of calibrated. Whereby A is the
amplitude.
Amplitude, good. Another.
No tiene razón.
Amplitude. So you might think of it as or vertical stretch. Vertical stretch scale factor is another way of looking at it. So the amplitude or vertical stretch scale factor. B is not the period.
No. 360 over the period.
Well done, good, yeah.
It says it affects the period.
Yeah, it affects the period, yeah, exactly. So it affects the period. Yeah, I'm spelling that right.
That looks like man every day.
Sweden, it's where I'm on this board. So period. So yeah, as you guys said, period equals 360 degrees over B, or 2 pi over B. Yeah. And that's the thing, as I said, people do get boo-booed on. They bite and think that B is the period, but it's not. What is C again? C is a nice one.
It's the horizontal thing. Horizontal shift.
Yeah, horizontal shift or horizontal translation. Yeah. Whichever one's fine. You understand what you mean. Horizontal translation or horizontal shift. D is the
Vertical translation.
Yeah. Vertical translation. So, some of you guys did trig graphs. I think Katie, you did a trig graph in your IA. So did Kiesha. I think it was just you two did trig graphs. And you had some trig functions in your IA. You did too? Oh yes, exactly. Yeah, that's right. So you had to wait till we kind of vaguely did it. Yeah, Sarah as well had a trig graph. I thought maybe you did. Yeah, because you had to wait till the previous topic. So Sarah, when you do your one by hand, you'll be kind of thinking like we are in this lesson and last lesson
Whenever
too.
you want by hand, do you want me to just do it on like a blank piece of paper like
That's what
You totally can if you want. Oh, by hand you can type it. It just means like you're finding your own, you're figuring out a function.
And then inside the algebra. That's why I do it by yourself, by hand.
You know how GeoGebra just spat out a model? This one you're going to work it out, like finding the amplitude, finding the value of
But I
theta.
worked it out by hand and then scanned it because during the computer all the images everything.
Yeah, you can handwrite it and then scan it too.
That's a lot of flies.
No, you've already graphed it. You're just finding the graph. You're finding the
I'm just
equation.
finding the equation and you're going to be in.
Okay.
Yeah, you're doing kind of like what's happening in this lesson, yeah.
I thought I had
Okay, so let's move on. So sine and cosine models can be fitted to data representing a number of different phenomena. So some people had in the past did an IA on, someone did an IA on ocean tides in Bermuda. So modelling ocean tides. Remember you get high tide and low tide? Shh, thanks. Come on, we've got to get through stuff because we're a little bit behind the others. So high tide and low tide. So see, it can vary a bit as well. So sometimes high tide's not exactly always the same time. Sometimes it's a bit lower than others and low tide. So modelling high tide, phases of the moon, like if you look at the size of the moon that you see, that kind of follows like trig graphs. Female hormonal cycles, like remember it's meant to be we're kind of in sync with the moon phases a bit. So that's why kind of sometimes some female hormonal cycles can follow something resembling kind of trigonometric functions, the fluctuations in hormone levels. Change in temperature over the year is another one. I think Yulia did that for her IA. She did changes in temperature in a city in Estonia, I think, or somewhere.
Estonia, classic.
Somewhere like that, I think. I might have that totally wrong. She did change in temperatures in some city and modelled that with trigs. The height of the cabin on a Ferris wheel. So remember we were talking about the London Eye. If you modelled the height as a cabin swings around a Ferris wheel, it resembles like a point P on the unit circle, doesn't it?
Kevin? like you said,
Kevin, as a point P, like a cabin on the London Eye, yeah, they call them like a cabin or a caboose. As one of these little things spins around, it's like Bella. It's like a point P. It's like a point P on the unit circle. Guys, we don't have time to mess around. So it's a point P on the unit circle, and if you model its height as it spins around, you'll get like a nice triggy graph. So imagine this one. With this little particular one, does the cabin start at the top or the bottom of the Ferris wheel? Right here. Oh, right here. Right here.
The bottom.
The bottom, yeah. And then it goes to the top, and then it hits down the bottom again as it spins around. So this is modelling its height. I don't know what that is. Its height as it spins around, basically. And this is its time with time. So time is the x-axis in that one. Some roller coasters, like Katie's roller coaster, had a bit of trig in it. So like modelling some roller coasters. So here's an example of another triggy one. Ooh. Follows these, makes it kind of thrilling if it follows this trigonometric pattern. Makes it nice and scary to be on. Heart rate monitors, like when you see in movies, or like if you go to visit a sick uncle or something, and they've got a heart rate monitor on.
When you go to an amusement park and you see like a roller coaster, right? You think like
No.
I was just thinking that.
If I saw one like this, I would. Yeah, like one like that. I would. But like sometimes, like when you first saw it, then yeah, when you first see one, you'll think that. But then you see so many after a while. Like
I
yeah.
love roller coasters. They're my favorite thing too.
Some are quadratic, some are a bit more quadratic-y as well. So, sorry, yeah, let's not get off topic. So, come on, let's not get off topic. Sorry to be pushy. So, heart rate monitors, like, changes in your heart rate. Notice they take, with each inhalation, the heart rate, like you're kind of spitting out blood, and it makes your kind of heart pump with each kind of breath. Yeah, like with each kind of breath. Is it breath or heartbeat? Or is it with each breath? Yeah, biology people. So is it yeah, you spit out blood.
It's like you mean your heart?
How does it work, Bella? So it's with each heartbeat, is it?
Yeah, but it's like I don't know how to explain it. It's not spitting blood. It's just the heart pounding because it's coming in from like the deoxygenated blood from the body, and then coming out. So it's like coming in contraction of the heart.
And I think what this is it like your blood pressure with each pump?
Yeah, because God gave you my pressure.
Yeah. So these are like single pumps, aren't they?
Like if you,
Okay. Okay, so high pressure, and then it hits low pressure, high, the next one. That's why it's going up and down like that. Okay, cool. And musical notes. So Calvina initially was kind of interested in doing musical notes because of the physics. So notice A, B, C, D, E. What changes as the pitches get higher?
Frequency.
The frequency, yeah. So they happen more rapidly, don't they? The higher the pitch, the more rapid. What do you think the amplitude vaguely represents? Anyone who does
The loudness.
The loudness, yeah. The volume. Yeah. So they're all the same volume. Notice all of these are the same volume, but some are higher frequencies than others.
So this can be radio stations too?
Radio waves, when they talk about radio waves, yeah, but that's what they're talking about, it's a frequency. Higher frequencies, the waves are closer together.
Where's Lauren?
She's doing the play. So
I know what that means.
below is a scatter graph. So let's go on the next page. We're actually making a few quick models now. So below is a scatter graph of average weekly temperature in a city. So we're kind of trying to do like changes in temperature over a week in a city. What kind of function do you think that would look? If this was your AA? A sine, yeah. Sine would make sense because it starts at the middle, doesn't it? Is the amplitude positive or negative? Positive, yeah, because it's not like upside down or anything like that. So we've got to work out its little amplitude. We've got to work out its D. To work out its D, I tend to try to work out where the principal axis is, and that tells you what the D is, basically. Because the principal axis is normally down at the 0. So if it's moved up or it's moved down, that tells you the D. So, to work out the amplitude, you kind of want to work out the highest Y and the lowest Y, and kind of find the difference between the two and halve it. And then, what do you think the C is going to be?
Yeah.
Has it shifted horizontally at all?
No, it's not 0.
Yeah, so there's no C, like as in like, so there's no horizontal shift. And vaguely, how would you work out the B? How would you work it out?
360 over 50.
Yeah. So this, I just looked at it on here. On my printout, it looks like it's at 50, but here it looks like it's a bit beyond 50, doesn't it? Like 52 or something.
This is why
Well,
this graph is annoying.
Will we use 50?
No, we should use 52.
Oh, accurate people. Accurate people.
Yeah,
Okay,
I don't be something over it. No,
So-
50. Make some even numbers. I have a feeling.
So just in case you forget what the general thing is, like it's y equals a sine b x minus c plus d, maybe let's work out what the a is first. I tend to find that easy. Or sometimes the a or the d. Amplitude, what we need to know is what's the highest point. What's the highest point roughly? 70, yeah. Yes, it's be really accurate if you want, just go 70. This I found a little bit hard to work out this one. What do you think it is with your better eyes than mine?
10.
No, so yeah, min at 10? Sure. Is it 10 or is it a bit higher?
It's a bit higher, but I mean,
We'll go 10.
10.
Yeah, okay, yeah, let's go min at 10, okay, sure thing. So let's work out the amplitude. What will be, is the amplitude 60?
Nah, it's like 30.
30, yeah, it's halfway from the top to the bottom. 70 minus 10 over 2 if you want, which will give you 30. So the principal axis is got to be at the halfway point between these.
See?
Yeah, good. So principal axis is at 10 plus the 30. Yeah, so at 40. So y equals 40. So therefore, d equals 40, yeah, because wherever the principal axis is, tells us what the vertical shift was. Because the principal axis was almost always at like a 0 for a regular one. So principal axis. So d is 40. You guys made a point that you noticed that there's no horizontal shift. Yeah. No horizontal shift. So c equals 0. And what's the period? Yeah. So we've got to work out the period stuff. What do you want to say the period is? Looking at the graph.
360
Oh, 50 when you use the period of 50, yeah? Yeah, and so therefore 50 equals, do you want to use degrees or radians is sometimes what you've got to decide.
Always degrees. Always degrees.
Always. Sometimes
And
degrees, quite often they use radians, to be honest.
Degrees. I think it's just degrees.
You're going to use degrees, use degrees, and I'll show you what it would be if it was radians. So you just pick one and commit. Like if the numbers are kind of in the hundreds, I tend to use degrees. If they're kind of less, I tend to use radians, so it's up to you. You can totally use degrees for this one too. So if it was in radians, it would be, I would use 2 pi over b. So therefore, how would I calculate my b? If I was to solve for b?
So you just do 2 pi over 50.
Yeah, 2 pi over 50, which simplifies to, because I can cancel down.
1 over 25.
1 over 25.
Pi.
Pi, yeah. Or over 25, yeah. So whichever way. If you do degrees, then you just use your degrees and simplify the fraction. Alright, so what have we got here? Did it say to use y or fx? No, it didn't say to use anything. So y equals 30 sine b is pi over 25. So I'm going to go pi x over 25, just my way of doing it. You could have put pi over 25x. So maybe that's okay to do that too. So I'll just show you that you can do that. Pi over 25x. And there's no horizontal shift, so I'll just put it all in a bracket. And then it's plus this one.
But is there, 40.
Thank you. Plus 40. So that's what you'll be doing. Looking at a max and a min, working out where the halfway point is, working out the amplitude, trying to decide did the principal axis shift up, did it shift down, is it still just where it is. Look at the period, If you've got small numbers, tend to use radians. If you've got big numbers, use degrees. And stuff. Shift sideways, that kind of thing.
If I have a graph that has like no correlation at all, should I just get rid of it? Or should I just be
Well,
like,
it's just gonna make you start from scratch.
Oh no, that's a different kind of thing.
on your evaluation, right?
How about like that? That would I don't recall. Oh, you mean I don't recall
one of
seeing
my
something.
graphs have no correlation and you're like, why have it? But like,
Oh, that I'm not sure, but like the other stuff you've done later is better.
Jump down.
okay, so
Yeah.
I should like just change my question.
Yeah, maybe. Yeah, that's a good idea. Because it turned out, yeah, you're right. Like it's good that you moved on to modelling instead.
Yeah.
Because it's good there. Yeah, but I didn't want like I thought let's just keep it just in case it does turn out to be relevant. But at this point, yeah, you'd be safe to cull that one.
Okay.
Yeah.
Just leave it.
Yeah, and just make it more about modelling then. Okay, so good. So steamships, cool. Here's another one. Here we don't have a graph, but they tell you things. So steamships, the paddle wheel of the SS Beaver, this thing here, it's a steamboat, was 13 feet in diameter. So it's a circle with a 13-foot diameter. It revolves 30 times per minute when moving at top speed. Using this speed and starting from a point at the very top of the wheel, that's a key thing. Write a model for the height in feet at the end of the paddle relative to the water surface at a function of the time t minutes. Assume the paddle is 2 feet below the water's surface at its lowest point. Interesting, hey?
So, our function will need to be a cosine.
Very good point. What? Say.
Because we're using the height here.
Yeah, and
You start at the
starts
very
at the
top
top,
of the
yeah.
wheel.
yeah, good. So use cos instead of sine.
It would be very beneficial to draw the unit circle at this point.
Yes, a unit circle, or alternatively, you could also kind of draw that and think of the x-axis as being the water surface. Oh yeah, and a circle, yeah. A circle with a 30 thing. And here's the water surface. Don't forget the water surface. Is here. So notice that at some point, how far below the water surface does it go?
A little.
A little.
Oh,
So what would be? So at the lowest point would be -2.
Oma. Okay, that's
What would be our height? And it's got a 13-foot diameter. So what is the highest point?
11.
11. Good. How did you get 11?
Where you see backwards? 13 subtract 2.
11. Yeah. So here's our height with respect to t. Here's our t.
the SS Beaver was the first steamship on the
Oh, and something. So now what we're going to do is we're going to come up with a model. So this is height. Okay, so we've got to now decide what is the amplitude. You might want to do.
11. No.
Good guess.
13 divided by 2.
Yeah, because it's whole height from top to bottom will be from 11 to here, so halfway. So it's actually 13. So the amplitude will be
6.5.
yeah. 6.5. Good. 6.5. Sometimes I like to start with the amplitude, and then sometimes the principal axis, which gives us the d, is helpful then. So the principal axis is where is the halfway point going to be? Is it 6.5?
Pardon? No.
Yeah.
Yeah. It's going to subtract 2.
Yeah.
So
Good.
4.5?
Yeah, it's two down. Yep. So the principal axis is that, or you can think of it as -2 plus 6.5 equals 4.5, same thing. So 4.5 will be wherever it is. So basically halfway between -2 and 11. So what does that tell us about our D? So D equals 4.5 feet. So we've got 3 things, so we've got 2 things so far. We've got our A, we've got our D. Is there any horizontal translation?
Is that 6?
The 6.5. And how do we get 4.5 as being the principal axis and therefore the D? Yeah, it's like halfway across, because everything's shifted 2 units down, like just said. Everything's shifted 2 units down, so it would have been 6.5, but because it's all been shifted 2 meters below the surface of the water, it's now 2 less than 6.5.
Different person in class.
And then, is there any horizontal translation? Yes, there is. So No horizontal translation, so C equals 0. So C equals 0. Another answer. Now the period is interesting. The key that tells us about the period is the little sentence. Yeah, 30 times per minute. And remember, T is our X thing. So it's done 30 times in 1 minute. So how long does it take to do one spin? So the period. So if it spins 30 times in 1 minute.
Catherine said 2.
2, yeah. How did you get 2?
Catherine said 2.
How? Tell me now. Yeah, 60 minutes in a, no, 60 seconds in a minute. 60 minutes in a minute. 60 seconds in a minute. Divide by what again?
30.
Oh, because it said 30 times. Got it. I forgot why. So 60 seconds, and it spins 30 times in 60 seconds. So the period is 2 seconds.
B, so B
equals.
So would you use degrees or radians if you've got a small number? If you've got a small number like 2, I suggest radians. But if you really, really want to use degrees, you use degrees.
B equals time.
Yeah.
On my IA, you told me to use radians, but I use big numbers.
It's probably just because of the nature of your data fitted with it. And it's because GeoGebra's default setting was radian. So that's why you use it. So it's okay. You really can use it. I'm definitely using it. So if you want to use degrees, you go ahead and use degrees. I'll use radians for this one because I'm just going to. So 2 equals 2 pi over b. Because then if I use, see if I didn't put the line. So then if I do that, yeah. So therefore b equals 2 pi over 2, which equals.
Hi.
So I've got a nice easy thing to shove in my formula. And they say h, call it h with respect to t. So h of t equals 6.5. Is it sine or cos?
Cos.
That's good, yeah, because there was no shift. So pi t. What was it again? Plus 4.5? Oh, great. Let's add that in. Plus 4.5.
It's not just for Friday.
So I have 2 classes on
Oh, wait, Tuesday, Thursday.
Well, for Tuesday, can't do a handstand.
Little one.
No, they're like 5 and 6.
There we go. That's our final answer for that one.
Insurance doesn't pay.
You have to teach them how to do handstands and it's still doing well.
Put them, like, make them do it on the wall, so they understand.
And the next one. Oh, you some people are writing.
La pregunta próxima.
There is a second. Remember, the first topic assignments, just while some people are writing that. First topic assignment. Yeah, I'll give it to you now, just because some people might want it. I'll give it tomorrow. I'll give it to you tomorrow, because then there's a lot of people away today.
They're going to be away tomorrow?
Yeah, Bella asked for it to be moved to Monday. Earlier in the week.
No.
So beforehand, the topic assignment was initially due, like this week, but due tomorrow.
That's sorry.
So topic assignment 1 was initially due tomorrow. Remember, it's only an easy one. But Bella begged the other day in class. Bella begged for it to be moved to Monday.
So it's due on Monday.
But you can hand it in today. You can totally or tomorrow. What I did say though, what I did say about that though, because remember when I said yes, I will move it, but just be aware there's a second topic assignment, so you're going to have a lot more work. So I can give it to you tomorrow. It's fine.
You said I begged for it.
You did. You begged. You were really beggy. You were very beggy. It worked though. So good on you.
I begged to get support.
Oh, okay. All right. So I don't know the level of what your beg can be. Actually, I clearly don't. It was a nice level of begging. You were pleading politely. Polite pleading. Okay, guys. I've got one more. Sorry. Okay, so I figured that it would take forever to draw this graph, so I started to do it, and I just missed a few points off. So a robot on Mars records the temperature on Mars every day.
I don't know if it works.
Yeah, well, good for you.
Every Mars day.
A summary. Oh, stop talking. A summary series showing every 100th Mars day is shown in the table below. So here we go. So what's this thing? The number of days. So how often do they record it? Every 100 days. Good, that's our X, yep. Temperatures in degrees Celsius. And they're all negative. So that's why the graph is kind of down there. So it would be pretty painful to draw this from scratch, so that's why I kind of just started it off for you. It just says now complete the scatter graph below. Which points are we missing? Yeah, missing these ones. So we're missing these ones. So we've got to plot these little ones. So 1,000 is at negative 15. You put it wherever it looks right on your one. I'll try to do it here. Yeah, it's awful, isn't it? 11, I think I had it on there and then I took them off. It's a bit mean of me. 1,100. Yeah, now. So now, yeah, I wish I had kept them. This is annoying. Okay, and then 1,200 is at negative 78. And notice that it goes up to 1,400, but the data doesn't. So we just go up to 1,300. Negative 68, where's that? Fabulous. So this is meant to be kind of what, when you do an IA and you model trig, like quite often your points aren't making a perfect sine wave, so you've kind of just got to just do your best at the point with what you've got. So we've got to write a sine function. They've told us do a sine. So sometimes they help you out, like they tell you you've got to do sine or you've got to do cos.
Yeah.
If it's a testy one. So on a test you could be given data and asked to find a model too. And normally they'll give you a clue, like they'll say do a cos or do b sine or something like that. Nice. So we tend to start with the amplitude. I tend to, anyway.
Are you not going to connect the line?
No. Oh, I did actually on my version. Where? Oh, Excel did it. Oh, probably because there's an actual point there.
No, it's the 0 for the X.
Yeah, it's probably because there's an actual point plotted there. If there was no point plotted there, they would have had no, nothing there.
No, it's still it's for the X.
Oh yeah, but if say there was no data point there, then I'm telling you something. If there's no data point there, Excel wouldn't have plotted it.
Okay.
Wouldn't have put the 0 there.
Okay.
All right. So, do you get that? All right. Now, so to find the amplitude, you've got to decide what's the max and what's the min.
The max is 0.5, negative 5.
Yes. Yeah, you could, or does someone want to say something different?
No.
So again,
You know what? I'll try to be dumb.
because you're modeling, like you just do your best. As in, like according to this one, see this one was over here was at negative 8. So some people might choose somewhere in between, like negative 6 or negative 7. But if you want to go, you just do the best that you just want to do. So
Can't you just look at the data book and see which one is the real max?
when you're doing real modeling, it varies. Like you're not always going to get max.
Yes, computer filter.
Yeah, like some, like this time the max was that, but maybe the next phase the max was going to be down here somewhere. The next phase. So you just kind of try to pick a roundabout because the real world doesn't follow perfect patterns. So the max here was negative 5, but like a couple of 100 days later, it was negative 8.
So then can you just pick the max is max?
You could, or what might be also smart is somewhere in between.
Oh,
That's you could do that, but it's okay. If you want to go with -5, we'll go with -5.
That's a nice number. We can give it.
Yeah,
It's -5 for this one, -8 for that one. So some people might have picked somewhere in between as the max. Because you just want to make a model that's kind of in between almost. But yeah, we can pick max at -5 if we want. What do we want to pick as our min?
Negative 79.
Yeah, thanks, right, yeah. So min at negative 79, let's do that. So how would we work out our amplitude?
Okay,
Yeah, subtracting from each other. -5 to minus negative 79. Yeah.
4!
Because?
4!
Oh. 2. 2. I don't know.
minus 5 minus 79.
So I guess you 84 divided by 2 would be 42. No, other way, sorry.
74 over 2,
Yeah.
which is
37.
yeah.
37.
Oh, okay.
So we've got A is 37.
Hey, this class is over.
No.
Okay, so
It's 220.
So guys, let's do this super fast because we've got, as I said, we don't have time to be wasting on this next lesson. So let's do this one really fast now. So we've got A is that. Our period is how many degrees roughly?
Degrees.
Oh yeah, we'll do degrees.
1,300.
What? Yeah.
I thought it has it done how
No,
many?
no,
Sorry.
You're right.
No,
The time it goes up, I can't see.
it's like 700. 700.
1,100.
Around 700?
700.
Yeah, I said 750, so we'll go 700.
700.
Yeah, you go with whatever one you want, yeah. We'll go 7. Yeah, just so long as it's kind of accurate is what we want. On mine, I said 7, I looked at the principal axis. Yeah, I went 752 because I kind of looked at the principal axis and there it cut there. Listen, or else we're going to go longer. Okay. Yeah, you don't waste time. Come on. No, you're fine. Okay, so what we've got is 750. I think 750 is better because see when you do the principal axis through here, it's kind of like more 750.
Okay, great. 750.
750. Okay, so 750 equals, what does it equal?
360.
360 over B. Good. So B equals 360 over 750. And that is simplified. Let's see. That was
36 over 75.
12 over 15.
Thanks.
12 over 15. Or 0.48 if you want to just do 0.48. So 12 over 15 if you want a fraction. The principal axis is roughly, how far do you think, like halfway between minus 5 and minus 79? You work out
37.
Yeah.
The difference.
minus 5, take away the amplitude, gives you about minus 42, wasn't it?
Excuse me, Miss Money, how we got 12 over 15?
Because you did 360 over 750.
Simplify the fraction.
Yeah, 360. What?
36 over 75, is that right?
That don't make any sense. I don't think it does either.
What's
That
36
would have to
over
be 45, not 75. Yeah.
75 is 15.
We divided by 3.
Oh yeah, maybe it's maybe I
It's 12 over 25.
Thank you, yeah, sorry. Thank you. 12 over 25, thank you. 25 for that one. And then, so D equals 42. And is there any horizontal shift? Is there, yeah, good. Because here it was meant to have started there. Good, so you got it. So our Y equals 37. And they said to use sine 12x over 25 minus 43. And then we're done.
And it's it. 42.
42.
42.
Okay, like 5.
So